Testing 1, 2, 3. Okay, I think we have probably 1 minute left, but or so. I think we can get going. So hi, I'm Chris Janiszewski, and this is Ken Holden. We are both OpenStack solutions architect working for Red Hat. So our job role is we travel around the country. We get to talk with a lot of awesome customers and help them translate the business challenges and business problems into the solutions around OpenStack and Ceph and Ansible, some the OpenStack related technologies. And we work with a lot of partners too. We work with a bunch of software vendors like Juniper, Cisco's, Nokia's, and hardware vendors. And we're here today to present to you our experience from integrating Keystone with in a large scale centralized automation in a large environment. So we're gonna try to make it as appealing to you guys as possible. So let me gauge how many OpenStack developers do we have here at the audience. Okay.
Mostly operators.
What about how many operators/architects do we have here in the room? Perfect. Good. All right. So just to let you know, since we are architects, we are not OpenStack developers. We will focus on the operational part of this problem. So we've done this together with Ken. We have done one presentation before. And it was, I think, a year ago in Boston, and we were talking about in-place upgrades using O. And in general we got the good reviews, but we had the one feedback that was not positive, and it said it was it was definitely not for the beginners. So we wanted to address that issue here. So the first solution we brought in, we marked this presentation as an intermediate, right? So this is a very easy solution. But we also want to solve it in a real way. So we want to start with with the level set, right? With going over some basics and making sure everyone is on the same page. Then we're going to give you our experience with, from the field, the benefits. Why do you really care? Why do you really want to do it? And so this is going to be a big part of it too. Issues and bottlenecks, best practices, and some tuning. At the very end, if you last long and you stay until the very end, we have a really cool demo for you to show you the results. What can you expect from doing it the right way? All right, so let me start with the level set. We're going to talk about authentication, authorization, what's Keystone, tokens, LDAP domains, Kerberos, and single sign-on. Okay, so authentication versus authorization. I'm pretty sure most of you know what it is, but just as a quick refresher, authentication means it deals with who you are, right? So it makes sure that the users that's being authenticated, it is who he says he is. Authorization is what this user can do afterwards. So authorization usually comes afterwards. Keystone is the OpenStack project. As you probably know, it's designed for the identity service. There's two methods of authentication. You can either use Keystone can either take advantage of the local SQL server, so your MariaDBs, your MySQLs, etc., or you can take advantage of something that's already out there in your businesses, such as LDAP. And after you're authenticated, you're gonna get the token is gonna be issued to you with the list of catalogs and what actions can you do or not. And of course you can, this all can be encrypted with X509. Okay, so what Keystone is, it provides identity, right? Token, catalog, and policy services. There's certain features that come with Keystone. It allow for the external authentication. We're gonna be focusing a lot about that in this presentation. I remember last time we were in Vancouver, I think it was 3 years ago, the second slide on a big keynote by Jonathan was Keystone Now Support Federation. And how many folks here, and I've seen there's a lot of operators, how many folks here actually use Federation in their environments? Okay. There's a good chunk. From my end, we didn't, like, when we talk to the customers, we don't see this service being as popular as promised back 3 years ago. I think it never really took off to the level that we anticipated it to take it off. There's also multi-factor authentication support, and every time maybe not every time, but very often when we're being bring into the customers, they put us against security folks, especially with the big banks and telcos. They want us to go for the security team first. And there's always some hard, the security people have the hardest job in the world, right? So they usually ask the hard questions. So I just want to get something out of the way. Consideration for Keystone, there's really no, the Keystone doesn't have any built-in, that doesn't know how to validate the login attempts, right? So user can some malicious person can easily attempt to do the brute force attack on your cloud, and Keystone doesn't know how to handle it. So there's some ways to remedy that. You can use external authentication that knows how to handle it. You can use firewalling, monitor your user activity. So your traditional way of handling the situation. The Keystone doesn't have anything like that built in. There's also no enforcement policies on password strengths or expirations and things like that. Okay, there's concept of tokens, right? Tokens are the authorization mechanism within OpenStack. By default they expire in 1 hour, but this is also variable. And they're usually passed with some larger structure, like let's say list of catalogs and endpoints, etc. There's multiple token types. I think the most popular we've seen in the past and probably still out there are the UUID tokens. The nice advantage about UUID tokens, they're very small. They're only about 32 bytes in length. One of the big disadvantage of those UUID tokens is they're persistent, right? So you have to store them in a database. And I think one of the most popular failure we've seen from the customers who use OpenStack in the not managed way or properly configured way is them growing the database to the amount, to the sizes that makes the OpenStack environment unusable. So they require a certain amount of maintenance, like flushing them once every so often. There's a concept of PKI and PKI-Z tokens. I've specially crossed them off. They're no longer supported in the new OpenStack. There's also persistent. The biggest disadvantage of them were, they're really large. And the bigger catalog of services you have, the bigger those tokens were. And the latest and greatest, maybe not that new, but the ones that everyone wants to be at is the Fernet tokens. And the biggest advantage is they're not persistent. So you don't have to flush them anymore from your database. And they're relatively small. They're like 200 bytes in size. But this process, the token process, it evolves all the time, right? So expect in the future there's going to be something else, right? Fernet is going to become a new UUID, right? I think there's some work towards JWT going on with the as a next generation token. So just keep that in mind. It's going to evolve. All right. What's LDAP? Everyone, or most of the people I know identify LDAP to Active Directory, right? I think it's the number. How many people uses Active Directory in their environments? Okay, you know why now? Like everyone here almost raised their hands, right? Throughout my career, I think I only seen one customer using Open LDAP. You probably don't know what that icon at the bottom is. It's the Apache DS. It's also supported with the OpenStack. Yep. But in general, LDAP is a way to simplify integration to identity authentication, right? And one thing to note, identity service, so Keystone must not be allowed to write the LDAP service to LDAP services. Okay, there's a concept of domains, and this is not new, but we see a lot of customers still using the old school approach to Keystone and multi-tenancy. So traditionally, in a Keystone v2, you had the concept of projects and then users and roles underneath. And for example, user A in one project could have a different role than user A in another project. Keystone v3 introduced the concept of domains, which are, think of domains as containers for the groups and roles and users. And the domain owner has access to this domain to add users, roles, etc. So it makes the multi-tenancy in a v3 more closer what you would expect from the multi-tenant cloud system. Okay, we're not going to talk much about Kerberos, but from user experience, there is a notion of not everyone want to type their password every time they access their cloud. Either it's a CLI or even a dashboard, right? So Keystone has been some time ago allowed to be moved as a standalone service to the HTTP server, and that gives us a little bit more ability to split the functionality of the like a password authentication and something like X509 or Kerberos to separate services. So we're not going to focus too much on Kerberos, but something for you to know it's out there too. And how the Kerberos work, we like this analogy of the carnival ticket booth, or you go to that booth and you request a ticket. It usually is valid for a day, and then the sales guy that sells you the ticket, he makes holes, they punch the holes, which rides are you allowed on or not. And then you can present this ticket to different ride operators, and he can let you in or not. Depends on the ticket you got. And the Kerberos ticketing system, the TGT, works very similar, right? You have expiration, TTL, and then you have access to certain services or not. Okay, so let me move on to some of the benefits you get out of the LDAP, and I wrote some of them out there, but I think the bottom line is you want this system you're building to be as easy to be consumable as possible to your end user, right? That's usually our end goal, right? When we go to the customer, we want them to feel like this is going to work in their environment. People will want to use that, right? It's not going to be obstacle, and LDAP integration with the OpenStack can provide that, and from many angles, right? It consolidates the user's repository, so you don't have to have a separate database in Keystone local database and have another one somewhere else. But also, if you do it right, if you tune it right, it's going to perform very well, and your users are going to love using it. And there's some considerations. There's still very few people that understand LDAP. It's hard to find them. Like, LDAP is not the coolest. Everyone wants to do containers, right? Or Kubernetes or something. No one wants to do the boring security stuff anymore. So because of that, there's still hard time. We have a hard time very often to find people who know LDAP when we work with the customer.
Or they know the Windows GUI. And
yeah.
You ask them how to do a specific filter or query, and they have no idea.
Yeah.
So that still is very common in large organizations.
Yeah. So I mentioned earlier there's no writes allowed. It's a good thing, right? But maybe some users would like to create something on the Keystone side or OpenStack side and be able to translate that to the LDAP. I heard that at least one more time. OpenStack itself, either Horizon or API or CLI, it's not always the front end to what the users are dealing with. Very often our clients, they put some cloud management platform in front of it or their own web entrance, and And so something to consider there. Do you really need LDAP if you use that? And there's some performance considerations too. If you don't configure LDAP right, and Ken is going to really give you some background about that, you can really kill the experience of the OpenStack.
All right, so now we're going to talk about tuning it specifically. So we'll get into more of the intermediate. So what I wanted to first start off with is what's causing the slowness in Keystone and the bottlenecks. If you're familiar with Mexico City, this is out my window in the Marriott Reforma when I was doing a project down there, where you have I don't know how people drive down there. It's insane. Anyhow, so we're going to talk about token performance and kind of really what makes OpenStack slow or fast, and how to handle large-scale LDAP. So we'll move on forward to that. So a couple things to start with, outside of LDAP tuning, just a few things not to do, right? So debugging is great, but when you enable it in LDAP, it really hits the performance hard. Actually, if you enable the debug on any of the services, it's not really a good idea, but it certainly impacts Keystone pretty heavily. The second thing is when I'm doing a production deploy or I'm scoping hardware for production deploy, for my Keystone controllers, I want SSD absolutely mandatory. I want multiple SSD if possible, where I can do a RAID 10 or a RAID 6 or something like that. You're talking about all your databases, thousands and thousands and thousands of calls, constantly hitting it for every time Keystone wants to do something, as well as all the other APIs, Rabbit and telemetry and so forth. And the last is kind of a no-brainer, but you'd be surprised how many large major corporations still use LDAP without any encryption whatsoever. So you may have Horizon, you may have public APIs that are SSL, but when the user makes a call, or when the Keystone controller makes a call to LDAP, it's actually sending it in the clear. I find that still baffling, but we see it very commonly. And often I see it's available, but there's SSL on another, but a lot of times I see that it's only non-SSL available, which is crazy. So that's something you certainly want to make sure. And we generally point the queries. You can choose we do a lot of network isolation, so choosing which network the Keystone controllers will query, the Active Directory or the LDAP servers is also a consideration, so that you don't have the ability for other people to sniff the network per se. So as Chris alluded to, tokens, FerNet's kind of becoming the default, but we still see obviously a lot of UUID out there. And like Chris was saying, with the persistence of the database for UUID tokens, every single time a token is queried, it has to look back into the database. And so that causes constant lag. So with FerNet, it's kind of a self-expiring encrypted entity that has the information that's needed inside of it versus it having to look back into a database. So just switching from UUID to FerNet is a huge improvement. And if you're doing multi-site or cross-site or any type of replication, this eliminates a lot of that database replication because you're no longer having to sync the tokens table in the Keystone database. So, regarding UUID, if you've been around Keystone for a while, you've probably run into the point where OpenStack just starts to crawl. Services start failing, can't log in, can't do API calls, anything like that. And through a lot of research and debugging, and you find out that you have, a few 100 million tokens, expired tokens in your database. What UUID does is it stores all this persistent data in the database, but it doesn't clean up after itself. So when you have a token that expires, it just sits there as an expired entity. And what happens is Keystone starts getting really tired. So they came up with a cron, the Keystone Managed Token Flush cron, routine, which you call via cron, which cleans up those. But if you ever run into this situation and you are trying to recover from it, you will know that the Keystone Managed Token Flush does not fix once the database has grown a certain size with regards to how many tokens are in it. So in certain situations, and actually this was right from a Bugzilla I grabbed for the Prezo, 149 gigs just for the Keystone database. I've seen them in the terabytes from tokens from large organizations. And the only way to fix it is to drop the database, to back up the database and drop the database, import everything but the token table, and it's a pain. It's case in point, one of the main reasons to get rid of UUID. So the next thing is, where do you query? And a lot of people don't know where to actually point your domain queries to, or how to make it resilient. But with Active Directory, this is kind of the most one we see. If you're using Active Directory DNS and it's working well and it's trusted, you can point to just the domain. And Windows DNS does a really good job of providing the LDAP server that's closest or most available to you via the SRV records, right? So you can do a dig with an SRV switch to actually get a list of your LDAP servers if you want. And you can list them all with a comma between. But the best way I find is this way, anytime you make a query, it's going to hit DNS for a time to live point. So it won't hit DNS every time per se, but it will hit DNS often enough that it may provide you a faster LDAP in an hour when Monday morning hit and everybody's logging in. So it's a good point with LDAP, like OpenLDAP or Oracle or things like that. It's not as intelligent, so I usually just give it a bunch of lists. But obviously, I'm calling out LDAP S, TLS for LDAP queries if you can. It's definitely should be a requirement. So the next thing is the records. So when we started doing Keystone deployments in very large scale deployments, you're talking about your Active Directory number of users is into the 100,000, 200,000 groups. You may have 40,000 groups. And so a lot of the quick thing you want to do is, all right, well, just point Active Directory or just point the LDAP search to the base DN, right? And what ends up happening is the way Keystone works is the first time you do a user list, I'm going to do an LDAP search. Well, Keystone will do an LDAP search in the back end and get all of the results from Active Directory or LDAP. And if it sees in this example, 129,052 users, it's going to create 129,052 entries in MySQL, one for each and every single user and group that it sees. Or user, actually, if you do groups, it's going to add the groups as well. They stay in there. They're in there really for no reason. Are all 129,052 users going to log into OpenStack? I strongly doubt it. So performance-wise, limiting that is huge. And one thing to note, if you do change this after the fact, that 129,052 users that were in Keystone will remain in Keystone, even though you filtered it down to, let's say, 50 users, because Keystone doesn't do a good job of cleaning up after itself. And the same thing goes with a deleted user. So when a user logs in, Keystone is actually going to look to SQL and then throw its authentication to Active Directory or LDAP. But it does have that skeleton record in Keystone. So just something to note, especially for security audits and things like that. So this is some examples of LDAP filtering and how we're doing LDAP filtering. So if you've set up Keystone with Active Directory or LDAP before, generally what we do is we create a domains folder inside of etc Keystone. And then we tell etckeystone.conf to point to that domains directory. And we create domain files in there. For example, keystone.lab.conf, right? So inside of there, I would create users filters and group filters. And so if you look at the syntax of these filters, these can get quite extensive. So what I'm doing here is an example of you're a user and you're a member of this group, or you're a user and you're a member of this group, this group, this group, or this group. So you can use that and/or type query, and you can get quite large with these expressions. So you're going to put them in Keystone. The one downside is you have to restart Keystone when you do it. So obviously figuring out the right strings first in your production environment is probably the best way to do it. And lastly, Active Directory does nested groups a little different than just traditional LDAP. And they've added this very convenient, easy to remember 1.2.840.11.356.1479. You got it. It's very easy, it just rolls off the tongue. That is something that Active Directory Microsoft created in, I think, Windows 2003 Service Pack 2 and Windows 2008 Service Pack 2, where it allows you to specify this OID in your LDAP query, and it will allow the nested group search to continue on down the line. If without that, though, you have some issues. And in older versions of Keystone, it didn't support this. So this came, I think it came in Mutaka, maybe backported a little bit, I'm not sure. But yeah, it was in the old days, we just basically had to not do nested groups. But now nested groups will work. Just be wary of that string. And the way you figure out these strings is they're LDAP search. So if you can do an LDAP search, you can create your filters. The syntax is exactly the same. So here, I have a couple different examples of the and/or and a nested group. But feel free to get elaborate with those types of queries. Mouse is Uh-oh. So one of the things in the last slide that I listed in my query was a -EPR. And this is giving me page results. So obviously in the olden days where bandwidth was slow, LDAP was designed to not give you all of your results back on a query because it could be quite large. Nowadays it's not too big of a concern. But if you don't tell an LDAP search to understand paged results, it will not give you the results you want. And for example, in this example, my lab, I had 10,000 users. So when I did my query and said list all my SAM account names, it gave me 825 lines because it failed. It basically reached the end of the first page and didn't move forward because the default is to not allow pagination. So by specifying in my LDAP search that -E PR equals 1 or more, it's allowing me to see more of the paged responses, and then I get my result. So with regards to how to set that in Keystone, we would basically tell it the page, use page underscore size, I believe it is, equals. So 0 is default, it's off, use 1 or more. And so next we talk about LDAP Debug. And this is kind of fun because I don't like to do debugging, but when you're trying to get it working, obviously you need to do it. So I set LDAP Debug into a level 3, which gives me more results back in my logging. And when I run this, I can grep for LDAP search, and you will actually see the Keystone server calling the Active Directory or LDAP server with the specific user or group filter that you created based on the querying that you're trying to do. So it's really nice because A, you get to see is there a syntax issue, because you can copy and paste right from there and translate it to an LDAP search. And it just kind of gives you a good representation of maybe why something's not working. And obviously, when you're done, disable it. These logs can get huge. That's a good way to fill your root file system. So be sure to disable them. Keystone Pooling is something that's been in there for quite some time. When an LDAP client makes a connection to an LDAP server, it's this concept of a connection pool is made. And every time an LDAP client makes a call, it creates a new connection. So when you have multiple connections and you throw in something like TLS in there, now you're putting an enormous amount of pressure on your LDAP servers to respond with those. So if you enable pooling, it's going to create a connection and then share that connection for other queries. And the same thing goes with user client authentication. You can actually separate the client authentication piece out to its own connection. So there's the two concepts of use pool and use auth pool. You cannot enable use auth pool unless use pool is enabled. So just an FYI. I generally enable them both, but there are some reasons not to, or some issues with specifics to tuning that I'll get into in a little bit. But for the most part, pooling is huge. And like Chris was saying earlier, with regards to SQL users and LDAP users, this is not something that SQL is going to take advantage of. So if you have local Keystone users, this doesn't apply to them. This is going into the LDAP piece of Keystone. So that's where you really see the performance gains. If you're just using a lot of local users, you're only going to be able to optimize to a point. This really does help, especially when you're dealing with large scale. Caching, this is the thing that I've found causes the most immediate and incredible performance gain. As like I said earlier, if you increase the performance of how you can get a token, how fast you can get a token issued, OpenStack will perform faster. So the better you can do it, the faster it's going to be. So what I did is I enabled memcache. It supports, the options are by default dogpile.cache.null, which is no caching, dogpile.cache.redis, and memcached. I found my best results with memcached. I'm still working on getting it to work well with Redis, or to work with Redis, but memcache was a no-brainer. I literally just enabled memcache on my local Keystone server, enabled these options in Keystone, so enable the caching layer. You're allowed to, you have the possibilities of enabling caching for not just tokens, but also things like federation or roles or token revoke and things like that. I enabled them all. I don't see a reason why you wouldn't. But the performance gains that you'll see in a little bit are huge. And with regards to the cache backend argument, like where we're pointing it at, I point it to the local IP address, not the 127 necessarily, but just an IP address of the local Keystone server that you're configuring it on, and not to a pool of memcache servers or a memcache pool. I've not had the best results with that, and there's some bugzillas around with regards to just that. So I find just pointing it to locally is the best way to do it. Obviously, restart Keystone, and we'll get into the performance from that in a second. So here's the results. Okay, so this is with my lab, which is 3 controllers. They're running their HP DL360 G7s, right? So they're dual proc. They got a bunch of memory in them. They're not new, but they're fast servers. So when I do a deploy with just the basic LDAP integration, no pooling, no filtering, no caching. I'm using Fernet, but I'm getting about for me to call 100 ask for 100 tokens. It took about 2 minutes, 55 seconds. This isn't going through the Python tools. This is basically just doing a curl to Keystone's API and requesting. It's the fastest way to get a response. But once I added filtering in, and the filtering doesn't make a difference until you get into large amounts, right? So in my case, my lab, and for these tests, had 10,000 users. But the larger that is, the more. And I've seen initial queries of 10 minutes. Where you have to enable the HA proxy timeouts and you have to bump them way up and things like that. It becomes really a pain. So once you bring filtering down to a reasonable level of users and groups, you're going to see some performance, and that line will continue to drop depending on how large your environments get. Pooling offered some benefit. I find that pooling benefit is good, but it's more about what it's helping the LDAP server that you're connecting to. But when I enabled caching, this is the insane part. And for each of these tests, I warmed the cache. I ran multiple tests prior. I'm running 3 controllers, so obviously I have to do it more than 3 times at least because I want local caches to fill up. But this is totally repeatable. From deploying an environment, nuking it, redeploying it, testing it, nuking it, redeploying, testing it. I've tested it multiple times. The performance is staggering. So when you get that type of performance, not only is the API fast, but to give you an example, this is Horizon. Let me see if I can full screen this. You can see it. That's good enough. So this is Horizon with LDAP filtering in place, user pooling in place, 10,000 users, but it's filtered down. And I'm just kind of clicking through it. And as you can see, it's waiting and waiting. I've gone through this GUI many times before creating this video to make sure that things were cached and it wasn't new and all that fun stuff. So this is kind of just, and without pooling and without caching, without pooling and without LDAP filtering, this is really slow. It's crazy slow, especially when you're logged in as an admin user, because you're doing more API calls. So as you can see, there's certainly lag in there, and it's just obnoxious. And then in a second, we're going to see what it looks like with caching enabled.
Is that an experience anyone at the audience is getting from the dashboard?
Yep.
There you go.
And it's, as I said, you'll see it in command line, but it's not as evident as it is in the GUI. You're expecting the GUI to be kind of instantaneous, right? So once I've enabled caching, here's what I get. Okay. So again, I'm logged in as an admin user, so I am doing more API calls. The slowest one is Nova. Nova seems to be the slowest to respond. But for the most part, everything is instantaneous. And again, I have done this. I've rebuilt it from scratch, enabled it, not enabled it, gone through a few days of using it, and then enabled it. The results are always the same. And this is the 3-node controller plane. So I'm running HA proxy. Every single hit is going to a different controller. So I'm basically round-robining amongst 3 controllers. So obviously, when you're testing this, if you have that scenario, you want to make sure that you've at least tried it a few times before you start to count how long it takes, because you have to warm up cache somewhat, right? So those are the things that I do to speed up Keystone, speed up OpenStack in general. But there are some caveats or issues that we've met with in the real world. One of the first one, and I start to see this a lot, this has been very common, is blue code proxies in front of Active Directory. Who's using blue code proxies in front of Active Directory in the room? Anyone? That's rare. Okay, normally, from what we're seeing in large scale, for whatever reason, because Active Directory does a really good job of handling connections and where to send connections to with regards to a busy server or not. People are putting they're putting blue code or some type of proxy in front of it. And what that does is that causes issues with the connection pooling. So where connection pooling will actually not work. And what you'll have happen is you'll enable connection pooling, and then you'll run a query, and it just doesn't get a response. It says, no users found, or no response back from the LDAP server. You run it again, goes through. So I usually disable connection pooling in that case. There's tuning you can do. I mean, obviously, it's most likely some type of timeout, or it's, there's not a persistent state that the proxy is keeping between the Keystone controller and the end user, the end domain controller. If you can point to the IP, a lot of times that's the other way around it, is to just try to bypass the proxy. But generally, they've been getting smarter about that and firewalling them off. So that's one thing. Firewall domain controllers, I don't see as often. I see this in the government a lot, especially in the military. So if you're using DNS for resolution of LDAP servers, like I was mentioning with Active Directory, it's going to hand you a list of 30 servers, and only 10 of them are reachable. So that means that 1 in 3 chance of your query being hanging. And when it hangs, it has to wait for the time to live fail. It takes forever. So in that situation, you usually want to statically assign Keystone to talk to specific LDAP servers. This one, the third one, was an unusual one. We had an issue where users were working just fine. I think we had something like 70,000 users. Users were working fine, but groups weren't. So none of the group role mappings that I was doing was working. And the reason being was that Keystone expected the group to respond with a fully qualified, distinguished name. So the group's name would be group, groups, name of group, or name of group, groups, blah, 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 domain.com. But instead, it was just giving me back name of group. And because there was no DN, or I've also seen with other specific object classes that weren't there, Keystone wasn't working. Now, that bug was addressed. So they did fix that in Keystone a while back. But nonetheless, it's kind of those weird things you see. That was with an Oracle identity management server. So the idea was that this was the character that Oracle was looking for in order to bill per users. So they found out if they didn't use that object class or whatever it was, they didn't have to pay Oracle as much money. But just a pain in the butt. Other things, obviously Keystone is using a service account with Active Directory specifically. Active Directory requires a user and a password to query. It doesn't care what the user or password's role is in Active Directory. Any user can query Active Directory. It's kind of one of those little hidden secrets. Any single user in Active Directory can list all records in Active Directory by default. So you need a service account, though. Obviously, you want a service account that you are going to know if the password is going to change. If the password changes and you don't know about it, well, users aren't going to be able to log in. And this is also a reason of, actually, I'll get that on the next slide. Another thing, certificates. So obviously, if you're using SSL certificates, by default, we're going to be asking for the LDAP server for a cert. It's going to validate what we know about that. Is it a trusted CA and so forth. If these change and you don't know about it, you're going to run into error where Keystone's going to say certificate not trusted or something of the like. Next thing is obviously all these things that I'm talking about require you restart Keystone. If you're running multiple Keystone servers, not that big of a deal. But just something to keep in mind. It's not something you'll be changing all of the time. So when you're crafting your filters, for example, craft them in a way that you don't have to change them all the time or add new groups to them. For net tokens are great, but they do require key rotation because they are encrypting the token. So it's just something to, And the last thing is the defiant Windows admin. I go into a site, I say, what is your LDAP server? Why? What is your OU? Why? And it's like I'm personally going to offend this person if I use their Active Directory for something else other than Windows. That happens actually more often than not, surprisingly enough. But then I wow them with my LDAP search skills, and they usually get confused. And, yeah. But so and lastly, the last thing I'm going to talk about, and the previous session was kind of about this, so it was actually kind of a good ending, is multi-site. I'm not a fan of extending Keystone, multi-region, stretching. I've done it. It works. But I don't like the idea of having to replicate all this database back and forth, especially with UUID tokens. Fernet made it a little bit easier. But I'm of the old school of, we did clustering. It had its day. It never worked when you wanted it to in the middle of the night on Christmas in a snowstorm. It would hang in some odd way and things would, whatever. So I like the idea of treating my data centers or my sites as completely separate clouds. If I have an OpenStack deployed in my East Coast data center and I have OpenStack deployed in my West Coast data center, why not treat them as two separate cloud providers? If you use a cloud management platform like CloudForms, you can push your applications and VMs out to both of them. So allow the app, the Cloudy app, to handle the resiliency, not the site. I should be able to expect that my entire data center goes down, and I don't care. But the thing is, with those data centers, most likely you have domain controllers, Active Directory, LDAP, on both sites. And LDAP does a really good job of replicating itself, so let it do its thing. Point each OpenStack to LDAP. They'll both have the same users, the GUIDs are the same, users, IDs, groups. However, the one caveat is when you create a domain in Keystone, when you create a project in Keystone, and when you create roles in Keystone, all of those have unique IDs for that Keystone that were generated. So if you're not replicating data, it's not too big of a deal. But when you start to do like object store replication or something like that, where, for example, Ceph Router's Gateway is going to care about the tenant ID or the project ID in order to allow a user to have read or write access to it, they need to be the same. So in that scenario, what I've done in a pinch is I've just basically looked at one site, grabbed the IDs that I needed, went to the other site, looked at them in SQL, and replaced them. Voila, it works. Not really a good automated way of doing that yet, but something to think about. And that was that. So we'll go start the question and answering, unless Christian you have anything to add.
No, I think we almost at the top of the hour, so we're going to take one or two more questions if there is any.
Yes. Blue Coat's a proxy. It's a proxy company, hardware appliance. It's just something, I see companies doing. Oh, it's owned by Symantec now? Okay, yeah, there you go. I'm not a big proxy guy. Yes.
When doing this sort of LDAP integration, is there any good way or any recommended way to avoid using sort of passwords in OpenRC files or in scripts or whatever, like application credentials, API keys, or something like that?
They're still there. With like your RC files, yes, there's a way of doing it. I can't recall off the top of my head, but you can basically, I don't know if it's salt or there's something you can add to your RC file if you Google it. Basically, where it asks you, once you source the file, it asks you for your password, and it won't ask you again. Right. But it doesn't store the password in there.
Right, and I think CERN had the same problem like
Kerberos would be a great
few years,
for that.
a few years back, right? So what they did, their users were asking for also the ability to, do the single sign-on, and they didn't want to store that password in a local RC file. So they did figure it out how to, since the Keystone is now pushed to the HTTPD, right? You can implement something like Kerberos on the back end, and then when you invoke your CLI command, you only have to type your password once, for instance, instead of saving it in a in a local text file in a clear text.
It's using KNet essentially. But,
Great, thanks.
Yeah. Anyone else?
All right.
All right. Well, thank you very much.
Thanks so much for coming.
This was helpful.